Good morning dear students. In this video we are going to see module 3 a linear time system properties in terms of the impulse response. So in that the first topic is system interconnections, how the systems are interconnected. First, systems are interconnected. First, parallel connection of LTI system. Systems are interconnected in two different types. Parallelly we can connect it, and series or cascade. First, we'll see parallel connection of LTI system. So in this here we can see. Here we can see parallel of LTI system. In that parallelly, see S1 is one system and S2 is the another system. These two systems are connected in parallel. The resultant output is nothing but a Z of n. Here Z of n is nothing but a parallel connection of Y1 and Y2. So here Y1 of n, here symbol is plus, Y1 of n plus Y2 of n is equal to Z of n. That is nothing but a parallel. So Z of n is equal to Y1 of n plus Y2 of n. That is equal to here the everything both we are going to consider as a response is nothing but a, so the first one, so this one we can write it as impulse response. The first response is impulse response of S1 and second one is impulse response of S2. So here S1 is nothing but a, X1 is our input and impulse response is nothing but a y1 of n, that is equal to x of n into h1 of n, that is nothing but the first y1 of n. Same thing y2 of n is nothing but x of n convolution of h2 of n will gives y2 of n. Now z of n is nothing but y1 of n plus y2 of n. Z of n is equal to y1 of n plus y2 of n, that is equal to, here y1 of n we already know, x1 of n x of n convolution y1 of n, x of n convolution h1 of n plus x of n convolution h2 of n is equal to, here we are going to take common of x in this both terms. X of n is common. You can take x of n is common, we'll get it h1 of n x1 of n convolution h1 of n plus h2 of n. So this is nothing but impulse response of the parallel two system x1 and x2, that we can write it as a x of n is equal to x of n, that operation we can write it as a z of n. So this is nothing but this whole thing we can write it as a impulse response of a parallel is the sum of the impulse response. Impulse response of parallel systems is nothing but sum of the impulse responses. Same thing we can do for the next one is series connection. Next is nothing but a series interconnection. Series interconnection of systems, we can call it as a cascade interconnection. So this is the simple block diagram of series interconnections. Here we have the two systems S1 and S2 is connected in series. So now we know that is nothing but S1 is our input. So that if you find the impulse response h1 of n, so convolution of x1 in x1 and h1 is equal to y of n. Now here z of n is nothing but a convolution of, here for the second input is nothing but a y of n. So y of n convolution of h2 of n will gives s2, impulse response of s2. Impulse response of s1 is equal to x1 x of n convolution h1 of n. Next one is impulse response of s2 is equal to y of n impulse response y of n convolution h2 of n, that is only here s1 and s2. Now we know what is z of n. Z of n is nothing but a this convolution, so that is nothing but a y of n convolution of h2 of n. This already, from this what is y of n? Y of n already we got in the equation number 1. If we substitute, we'll get it as a y of n is x of n convolution h1 of n, again convolution h2 of n, that is nothing but x of n convolution h1 of n convolution h2 of n. So impulse response of the series of s1 and s2 is s1 of n convolution h2 of n. So here we can call it as a impulse response of the series is the convolution of the impulse response. Impulse response of the series is convolution of that impulse response of the two signals, that is h1 of n convolution h2 of n. Next we will see some problems. So now we can see one problem. Given impulse responses of each subsystem for the interconnection of the system, for example find the total system output. So we need to find the total system output for this block diagram. Here x1 of n is nothing but input and y of n is nothing but output. So here you can see already we just now we saw the two systems are connected in parallel, means that is a parallel connection, that is based on the symbol we need to add or subtraction. Both two systems are connected in series, means we have to multiply. So now we are going to minimize this block. First one is h1 of n and h2 of r connected in parallel. So h1 of n plus, here both are plus only, h1 of n plus h2 of n. So that resultant is series with h3 of n, correct? So now we can write it as a h1 of n plus h2 of n into h3 of n into h3 of n. Again this whole resultant is again this whole resultant is series with h4 of n. Then we need to add, here this is nothing but the whole thing is plus and this is minus, means minus h4 of n is equal to y of n. The total output of the system y of n is equal to first h1 of n plus h3 of n of multiplication h3 of n, that whole thing we need to subtract with h4 of n, because here minus, that only gives the total system response output. Now the interconnection of LTI system for the problem. So here this one more problem we are going to draw. So the interconnection of LTI system for this problem, h5 of n. So we need to, here they gave the overall system. The previous problem they gave the block diagram. From the block diagram we are going to write that overall system response. Now suppose if they give the overall system response, how to draw our block diagram? So now our h of t is equal to, the overall system is equal to h5 of t star h1 of t convolution h4 of t minus h2 of t plus h3 of t. So we have to start always the last one. So these two, see, h2 of t plus h3 of t is both are connected, plus is nothing but a parallel. First from the input you consider h2 of t, h3 of t parallel, both are plus. So h3 of t, h2 of t plus symbol using the summer, we got it, that is nothing, that minus these two are connected in h1 of t and h4 of t is connected in series. So is connected in series. So convolution is nothing but a series. So h1 of t convolution h4 of t, from the input we are going to connect it as a series. This is the plus and minus. So to add this one we are going to use one more number. This is nothing but a series connection of these two systems and parallel connection of these two systems. To subtract, one is plus, this is plus, series is plus and parallel is minus. Using the summer, if you add this one, we'll get the output. So that result is convolving, that result is series with h4 of n, that is the whole result is series with h5 of t, that is only y of t, h5 of t, that is y of t. So by using this one we can do vice versa also. If you want to draw the overall system response in a block diagram, we can draw. If they are giving a block diagram, from the block diagram if you want to find the overall system response, we can find the overall system response from the block diagram. I hope you understood, and remaining topics we'll see in the next class. Thank you all.